The next part of trying to graph some polynomial functions, after we understand their end behavior, is to find out, does this function cross the x-axis? And if so, how many times? So looking at this particular function, to know where it crosses the x-axis at, we're basically asking ourselves, where does f of x equal 0? So let's find out. X cubed plus 3x squared minus x minus 3 equals 0. Well, if we draw back on some of our prior learning, we learned that sometimes we need a factor in order to find out where does it cross the x-axis at. And this one is a factorable term if we remember that we can factor by grouping. So factor by grouping means that I'm going to try to factor out a binomial from these first two terms and these second two terms, which I'm going to factor out a -1, and I'm left with an x plus 3. And I can see that I have an x plus 3 common to both sides. And I'm left with an x squared minus a 1 equals a 0. And from that, I can determine that this is true if x were equal to -3. And it's also true if x were equal to, where is x squared minus 1 equals 0? It's where x squared equals 1. So x can be plus or minus 1. -1 squared produces a 1. Positive 1 squared produces a 1. So this particular function crosses the x-axis at 3 spots. It crosses it there at -3 and 0. It crosses at 1 and 0. And it crosses at -1 and 0. So as I start to get an idea of this particular graph, I know that I have a crossing point at -3, a crossing point at 1, and a crossing, or a -1, and a crossing point at 1. And if I looked at its end behavior, I notice the first term is positive, so that tells me it falls to the left and rises to the right. And that it's an odd term, so that there's 2 wiggles in there. So I'll probably have a wiggle that looks like that. And that starts to help me fill in some of the gaps that I may not have known before. Kind of cool, isn't it?